In the night logs of London Civil Defence, an impact is recorded that occurred without a preceding siren. The interval between the first acoustic signal and the explosion did not exceed a few seconds. Observation posts registered no luminous trace in the sky. Radar stations produced no stable return. At the impact site, no fragments of a rocket body or remnants of an engine were found. The crater showed sharply defined edges consistent with a high-mass artillery shell. The report states, type of munition not identified. In the following days, similar entries appear repeatedly. The times of impact vary. Directions are unclear. In some cases, the sound wave is registered after the explosion rather than before it. In other cases, the warning is issued only after damage has already occurred. Engineering reports indicate a trajectory that does not correspond to known systems. In documents adjacent to entries on the V-2, other, more cautious formulations appear. In staff summaries there is no explanation, only a recurring notation, launch not detected. Across the channel, in the chalk hills, underground work continues. Access galleries are camouflaged. Rails run into the depths. The angle of inclination is fixed in drawings. The length has no precedent. In the night summaries, an empty line remains where the source of fire should be. From the summer of 1942 onward, technical memoranda circulated within the German Army Ordnance Office describing a long-range artillery concept intended to exceed the reach of existing railway guns and fixed coastal batteries. The documents referred to a smoothbore weapon of extreme length, supported by a sequence of auxiliary propellant chambers arranged along the barrel. The stated purpose was the delivery of high-explosive projectiles to targets at distances previously unattainable by conventional artillery. Calculations attached to the memoranda listed theoretical ranges exceeding 150 kilometers under controlled firing conditions. The design was identified in internal correspondence as a high-pressure pump gun, Hochdruckpump, a term describing the staged ignition of secondary charges to maintain projectile velocity over an extended bore. Engineering responsibility for the concept was distributed between departments subordinate to the Army Weapons Office and private industrial firms contracted for specialized components. Krupp engineers examined barrel metallurgy and rifling tolerances, while Rockling provided expertise in longbore fabrication and pressure distribution. Reports from these firms emphasized the need for incremental propellant ignition synchronized with projectile travel, noting the requirement for precise timing mechanisms and stable propellant formulations. Early laboratory tests focused on the ignition reliability of side chambers and the erosion effects on barrel steel. By late 1942, ballistic tables prepared by the Army Ballistics Institute showed projected muzzle velocity significantly higher than those recorded for the Paris gun of the previous war. The tables listed projectile weights in the range of 140 kilograms and indicated apogees approaching the lower stratosphere during flight. These figures were circulated with cautionary notes regarding barrel life and the logistical burden of ammunition manufacture. Nevertheless, the documentation authorized further development and the identification of suitable firing sites. Reconnaissance and survey units examined locations along the Channel coast where geological conditions permitted deep tunneling and stable concrete emplacements. A site near the village of Mimoyecques in the Pas-de-Calais region was selected on the basis of chalk strata, rail access, and proximity to the intended target area across the channel. Construction directives issued in early 1943 ordered the excavation of inclined shafts oriented toward London, each shaft designed to house a fixed gun barrel anchored in reinforced concrete. Plans called for multiple barrels arranged in parallel, supplied by underground galleries containing ammunition stores, power lines, and crew quarters. Organization Todt assumed responsibility for construction. Daily logs from the site recorded the arrival of forced laborers, mining specialists, and engineering personnel. The work proceeded around the clock, with shifts assigned to excavation, concrete pouring, and rail installation. Ventilation shafts were bored to remove chalk dust and exhaust gases, and electric lighting was installed in the galleries. Security detachments controlled access roads and established camouflage measures intended to conceal surface activity from aerial observation. Technical reports sent from the site to Berlin described the challenges encountered during excavation, including water ingress and roof instability in certain sections. Adjustments were ordered, including additional concrete lining and modified drainage channels. Despite these issues, progress summaries listed completed sections of the main galleries and the partial installation of steel barrel segments delivered by rail under guard. Each segment was logged by serial number and inspected for dimensional accuracy before placement. Parallel to construction at Mimoyecques, experimental firing trials were conducted at proving grounds in occupied Poland. Shortened test barrels equipped with multiple side chambers were mounted horizontally and instrumented with pressure gauges. Firing reports from these trials documented irregular ignition sequences during early tests, resulting in pressure spikes and projectile deformation. Subsequent modifications to propellant grain geometry and ignition wiring improved consistency. By mid-1943, test firings achieved sustained acceleration over several chambers without catastrophic failure, as recorded in the firing logs. Ammunition development proceeded concurrently. The projectile design incorporated fins for stabilization, as rifling was impractical for a bore of the required length and pressure profile. Manufacturing instructions specified hardened steel bodies with internal cavities for high-explosive fillings. Tolerances were tight, and quality control reports noted a high rejection rate during initial production runs. Adjustments to machining processes reduced variance, and monthly output figures were revised upward accordingly. Throughout this period, intelligence summaries from the German military noted increased Allied aerial reconnaissance over the Pas-de-Calais. Construction reports included entries describing temporary halts in surface work during daylight hours and the extension of camouflage nets over spoil heaps. Despite these measures, air raid warnings became more frequent. On several occasions in late 1943, bombing raids targeted nearby rail lines and villages, causing delays in material delivery. Damage assessments recorded broken rails, destroyed rolling stock, and casualties among laborers. In response, directives ordered the acceleration of underground work and the stockpiling of critical components within completed galleries. Electrical generators and compressors were installed below ground to reduce reliance on vulnerable surface infrastructure. Communications cables linked the site to regional command centers, with redundant lines laid to mitigate damage from bombing. Internal correspondence during the winter of 1943 to 1944 referenced the weapon under a new designation, emphasizing its role as a long-range bombardment system distinct from rocket-based projects. Distribution lists for these documents were limited, and recipients were instructed to maintain strict secrecy. The correspondence included firing schedules contingent upon the completion of construction and the availability of trained crews. Training programs for artillery personnel were initiated at separate facilities. Manuals issued to these units detailed loading procedures, ignition sequencing, and safety protocols specific to the high-pressure pump system. The manuals emphasized adherence to timing intervals and listed emergency shutdown procedures in the event of misfires. Logs from the training facilities recorded classroom instruction followed by supervised drills using inert components. As construction continued, Allied bombing intensified in the region. Aerial photographs taken by reconnaissance aircraft showed increasing disturbance of the terrain around Mimoyecques. German countermeasures included the deployment of anti-aircraft batteries and the dispersal of decoy installations. Site logs recorded several direct hits on surface structures in early 1944, resulting in the loss of equipment and personnel. Repairs were undertaken where possible, but some damage was noted as irreparable. On July 6, 1944, a large-scale bombing operation targeted the Mimoyecques site. Bomb damage reports compiled afterward described the collapse of multiple shafts and galleries following the detonation of deep penetration bombs. Survey teams documented blocked access tunnels, flooded sections, and the displacement of barrel segments. Casualty lists were appended to these reports, noting fatalities and injuries among construction workers and guards. Subsequent entries in construction logs indicated the suspension of major work pending assessment. Engineering evaluations concluded that clearing the collapsed sections would require extensive excavation and resources. Communications to higher command summarized the condition of the site and the status of installed components. Alternative measures, including the redeployment of shorter barrels for mobile use, were referenced in technical notes. Elsewhere, limited operational use of a shortened version of the weapon was recorded during the same period. Firing reports from units equipped with these smaller systems documented launches against targets at distances significantly less than those projected for the fixed installation. The reports included data on projectile dispersion, impact times, and observed effects. These documents were circulated among ordnance and artillery offices for review. Throughout the summer of 1944, memoranda continued to reference the long-range gun project in status updates. The language of these documents remained procedural, listing material inventories, personnel assignments, and infrastructure conditions. No firing schedules were issued for the Mimoyecques installation during this time. The site remained under intermittent air attack, and security reports noted increased Allied ground activity in the surrounding areas. By late summer, correspondence from regional commands focused on the preservation of technical documentation and the evacuation of surviving equipment where feasible. Inventories were compiled, and selected components were ordered transported to storage depots further inland. Construction personnel were reassigned or withdrawn, as recorded in personnel rosters. All documentation from this period maintained a formal tone, recording actions taken, resources expended, and conditions observed. References to the intended range and performance of the weapon remained within technical annexes and ballistic tables. The records did not include narrative descriptions beyond the scope of operational reporting. By August 1944, administrative traffic concerning the long-range gun program shifted increasingly toward inventory control and documentation transfer. Filing directives issued by the Army Ordnance Office ordered that design drawings, ballistic calculations, pressure charts, and metallurgical reports be duplicated and distributed among several secure archives. Clerks logged each packet by reference number and date, noting the originating department and classification level. Courier routes were altered to avoid regions under frequent air attack, and receipt confirmations were required within set time frames. At the same time, technical staff attached to the program continued bench-level work on components not tied to the Mimoyecques installation. Workshops in central Germany recorded ongoing testing of ignition circuits and propellant casings. Daily test logs listed ambient temperature, humidity, electrical resistance values, and burn rates. Engineers adjusted insulating materials around ignition leads to reduce signal loss over long distances. Reports noted marginal improvements in synchronization between primary and secondary charges, measured in milliseconds. A separate series of documents addressed barrel wear. Metallurgical examinations of test sections showed accelerated erosion at the junctions where side chambers intersected the main bore. Microscopic analysis reports described pitting and microcracks consistent with repeated high-pressure exposure. Recommendations included modified chamber angles and revised steel alloys with higher chromium content. Procurement requests were submitted for experimental alloy batches, with delivery dates projected several months ahead. Operational reports from field units equipped with shortened high-pressure pump guns continued to arrive through September 1944. These reports followed standardized formats, listing firing coordinates, elevation angles, charge configurations, and meteorological data. Impact assessments were limited to time-on-target calculations and dispersion measurements derived from observation posts. Instances of misfire were documented with accompanying technical remarks, including incomplete ignition of secondary chambers and projectile instability shortly after launch. Intelligence summaries compiled by German air defense commands included references to Allied interest in unusual artillery installations. Intercepted communications and reconnaissance photographs were appended to these summaries. Analysts annotated images with estimated shaft depths and tunnel orientations based on shadow analysis and crater patterns. These annotations were circulated internally but did not prompt new construction orders. Within the ordnance bureaucracy, the long-range gun remained categorized separately from rocket weapons. Budget sheets from late 1944 showed reduced allocations compared to earlier quarters, with line items marked for maintenance rather than expansion. Accounting notes recorded the redirection of skilled labor to other artillery and air defense projects. Personnel rosters showed a gradual reduction in staff assigned exclusively to the high-pressure pump system. Despite these administrative changes, theoretical work persisted. Ballistic offices continued to refine trajectory models using updated atmospheric data. Tables produced during this period incorporated seasonal wind profiles over the channel region and adjusted drag coefficients based on wind tunnel tests of scale projectile models. Marginal notes on these tables reference the need for further empirical validation, contingent on future firing opportunities. In occupied territories, remnants of construction activity at Mimoyecques were periodically inspected by engineering detachments. Inspection reports described collapsed galleries filled with chalk debris and water. Structural diagrams were annotated to indicate inaccessible sections. Attempts to salvage embedded steel components were deemed impractical due to the risk of further collapse. Surface inspections recorded vegetation growth over previously disturbed ground and damage from repeated bombing. Security reports from the area noted sporadic encounters with Allied patrols and increased civilian movement following the disruption of German control. Guard units logged their withdrawal from fixed positions and the dismantling of remaining surface installations. Camouflage materials were removed or abandoned, as noted in quartermaster inventories. In Germany, experimental ammunition stocks were counted and reclassified. Warehousing logs listed quantities of unfinished projectile bodies, propellant charges, and ignition assemblies. Some items were reassigned to research institutions for metallurgical or chemical analysis. Transport orders specified destinations and handling instructions, emphasizing the sensitivity of propellant materials to shock and temperature variation. Training manuals issued earlier for the operation of the long-range gun were recalled in part. Circulars instructed unit commanders to return copies for revision or destruction, depending on classification. Receipt logs show staggered compliance dates. Revised manuals omitted site-specific references and focused instead on generalized high-pressure artillery principles. Correspondence from late 1944 includes several technical inquiries regarding the feasibility of adapting the staged charge principle to conventional artillery calibers. Memoranda exchanged between ordnance engineers discussed scaling issues, including chamber spacing, ignition timing, and projectile integrity at lower velocities. No implementation orders accompanied these discussions. As the year progressed, air raids increasingly affected industrial centers associated with the program. Damage reports from factories manufacturing ignition components detailed destroyed machinery, power outages, and workforce casualties. Repair estimates were appended, often noting shortages of replacement parts. Production schedules were revised downward accordingly. By December 1944, the flow of documentation concerning the long-range gun diminished. Remaining reports focused on archival matters, personnel reassignment, and the disposition of test equipment. A small number of technical staff were retained to answer inquiries and maintain records. Their activity logs list routine clerical tasks and limited laboratory checks on stored components. In the final weeks of the year, directives from higher command emphasized consolidation of research efforts. Projects without immediate operational deployment were instructed to preserve essential knowledge while minimizing resource expenditure. The long-range gun program appeared in these directives only as a reference code associated with stored materials and archive designs. Throughout this period, the tone of all surviving documents remained consistent with operational and administrative reporting standards. Entries recorded dates, quantities, measurements, and actions taken. Descriptions were confined to observable conditions and executed orders. No commentary beyond procedural notes was included in the official records. By January 1945, remaining administrative references to the long-range gun were embedded within broader ordnance and logistics traffic. Filing registers from the Army Ordnance Office show that the project code continued to appear in cross-indexes associated with experimental artillery, though no new construction or deployment actions were listed. Clerical entries recorded the transfer of responsibility for residual materials to regional depots under standard artillery accounting procedures. Technical correspondence from this period reflects continued attention to air defense reporting from the Channel region and Western Germany. Situation reports compiled by Luftwaffe and Army liaison staffs listed ongoing Allied rocket and artillery impacts, distinguishing between ballistic trajectories observed from rocket launches and flatter trajectories associated with conventional artillery fire. These reports included time-of-flight estimates derived from sound ranging and flash spotting. Analysts noted instances where impacts occurred without preceding engine noise or visible exhaust trails, categorizing such events under long-range gun fire when applicable. Civil defense logs from affected urban areas recorded alerts triggered by acoustic detection networks. Siren activation times, shelter occupancy numbers, and all-clear signals were documented in standardized formats. In several entries, civil defense officers noted uncertainty regarding the nature of incoming fire based on available indicators at the moment of impact. These logs did not attempt classification beyond the immediate operational need to issue warnings and assess damage. Within German command structures, memoranda circulated regarding counterintelligence and information control. Instructions emphasized limiting discussion of experimental artillery capabilities in non-secure channels. Field units were reminded to use approved terminology when referencing unusual weapons effects in reports. Compliance audits were logged, showing inspection dates and findings related to document handling. At research institutions still functioning in early 1945, theoretical artillery work continued at a reduced pace. Laboratory notebooks from ballistics departments contain entries dated January and February detailing calculations related to projectile stability at high altitude. These calculations used atmospheric density figures updated from meteorological stations. Marginal notes reference the need to account for temperature gradients and wind shear, with no indication of imminent testing. Reports from ammunition depots show continued storage of high-explosive projectiles originally manufactured for the long-range gun. Inventory sheets list lot numbers, explosive filler types, and storage conditions. Periodic inspections recorded humidity levels and the condition of casings. No distribution orders were attached to these inventories during this period. On the Allied side, intelligence summaries compiled from reconnaissance, prisoner interrogation, and captured documents referenced German long-range artillery projects alongside rocket systems. These summaries categorized weapons based on observed effects, estimated range, and launch signatures. Analysts noted that artillery-based systems produced fewer detectable launch indicators compared to rocket weapons, based on field observations available at the time. These summaries were circulated among operational commands responsible for air defense and strategic planning. Damage assessment reports from cities affected by long-range fire included measurements of crater dimensions, fragment dispersion, and structural damage patterns. Engineers documented these features to assist in identifying munition types. Reports from January 1945 list several incidents where impacts were attributed to artillery rather than rockets due to the absence of rocket debris and the characteristics of the craters. These assessments remained provisional, pending further evidence. Air raid precaution services continued to refine their procedures based on incoming data. Training bulletins issued to wardens and observers included updated guidance on recognizing different types of attack indicators. These bulletins focused on observable phenomena such as sound delay, flash characteristics, and impact timing. They did not include strategic commentary, remaining confined to practical instruction. German field artillery units received periodic updates on ammunition conservation and firing discipline. Orders emphasized accurate record-keeping of all experimental firings, including those conducted for calibration or testing purposes. Firing logs from remaining test ranges show limited activity, primarily involving pressure tests and inert projectile launches. Each entry lists crew assignments, equipment status, and environmental conditions. Transportation records from rail authorities indicate sporadic movement of oversized artillery components during this period. Waybills list destinations associated with storage or repair facilities. Escort requirements and routing instructions were included, reflecting concerns about air attack and infrastructure damage. Delays were common, with annotations citing destroyed bridges and congested lines. Medical and personnel records associated with the long-range gun program continued to be updated. Hospital admission logs list injuries sustained during handling of heavy components and from air raid incidents at storage sites. Personnel files show reassignment of specialists to other units or research tasks. Termination of project-specific postings was recorded without commentary. In occupied areas previously associated with construction activity, Allied engineering units conducted surveys following their advance. Survey reports described underground structures, measuring tunnel dimensions and documenting construction techniques. These reports focused on safety and demolition requirements. Photographic documentation was attached, showing collapsed shafts and reinforced concrete sections. The reports did not include speculative analysis beyond immediate engineering concerns. Captured German documents were catalogued by Allied intelligence teams. Index cards list titles, dates, and originating offices. Items related to long-range artillery were filed under experimental weapons. Translators produced literal renderings of technical terms and procedural language. Annotations clarified measurements and units where necessary, without interpretive commentary. In London and other affected cities, municipal records continued to log the operational impact of long-range fire. Repair orders, utility service interruptions, and transportation delays were recorded chronologically. These records reference the timing of impacts relative to warning signals. No distinction was made in municipal documentation between artillery and rocket attacks beyond what was necessary for immediate response. By February 1945, German high-level directives increasingly emphasized the safeguarding of personnel and records. Orders instructed units to destroy or evacuate sensitive materials if capture appeared imminent. Compliance reports note the burning of selected files and the relocation of others. The long-range gun project code appears in these reports only as an item in lists of materials handled. Remaining technical staff associated with the program submitted final status summaries. These summaries listed outstanding components, unresolved technical issues, and the location of archived documents. The format followed standard reporting templates, with sections for materials, personnel, and facilities. No forward plans were included. Throughout early 1945, the operational environment continued to change rapidly. Daily situation reports from both German and Allied commands maintained their established structure, recording movements, engagements, and material status. References to long-range artillery appeared intermittently within these reports, always in the context of observed fire or intelligence assessment. All surviving documentation from this phase adheres to contemporaneous reporting conventions. Entries are dated, factual, and limited to immediate observations or executed orders. Language remains technical and procedural, reflecting the constraints and priorities of the period in which the records were produced. By March 1945, references to the stage-charge long-range gun were most frequently encountered in intelligence filing systems, depot inventories, and engineering survey notes compiled in areas newly reached by Allied units. The project name and associated code numbers appeared in captured correspondence bundles that had been removed from offices and placed into transport crates during earlier evacuation efforts. Allied document teams recorded the locations where these crates were found, the condition of the papers, and the markings on covers and envelopes. Sorting sheets show that artillery-related material was separated from rocket-related material at the point of capture, based on document headings, diagrams, and terminology used in German technical language. Allied engineering reports prepared during advances in northern France continued to note the remains of deep shafts and reinforced galleries in the Pas-de-Calais region. Survey detachments assigned to check for mines, booby traps, and structural hazards entered accessible sections and measured gradients, tunnel widths, and lining thickness. The most frequent notations concerned blocked passages, water-filled sections, and unstable roof conditions in chalk. Reports listed the tools used for inspection and the periods during which the galleries were occupied by survey personnel, with safety officers assigned to monitor air quality and the risk of collapse. Photographic records made during these inspections were filed with captions stating date, location, and orientation. Concrete support frames, rail tracks within galleries, and partial mounts intended for fixed barrels were documented where visible. In some cases, survey teams marked areas for subsequent demolition or sealing, describing the placement of charges and the estimated mass of explosive required for collapse. Where demolition was executed, the results were described in post-action engineering notes, listing the size of the resulting cave-ins and the effect on remaining void spaces. Captured construction logs and work orders from the same area provided additional procedural detail. These documents contained shift schedules, delivery records for cement and steel, and lists of assigned labor. The entries reflected routine administrative concerns, shortage of timber for shoring, delays in rail deliveries, and interruptions following air raid warnings. Several sets of orders included directives for continued excavation and reinforcement following earlier bomb damage, followed by later entries indicating abandonment of sections due to repeated collapse and flooding. In Germany, as transportation and communications deteriorated, depot records show increasing difficulty maintaining standardized reporting cycles. Some inventories were updated irregularly, with annotations stating that inspection could not be performed due to air attack, power loss, or staff absence. Where the long-range gun program appeared, it did so as a set of items held in storage, ignition assemblies packed in insulated crates, propellant charges in sealed containers, projectile bodies in racks, and instrument sets used during proving ground firings. Depot officers recorded the condition of seals and the presence of corrosion, and requested additional preservatives where available. Ballistics offices still functioning in March 1945 produced a limited number of computations related to staged charge firing. These computations were filed as drafts and working sheets rather than fully issued tables, and they bore notes indicating incomplete data sets. The calculations listed pressure curves intended to reduce peak stresses in the main bore by distributing acceleration through timed sidechamber ignition. Marginal notes identified earlier pressure transducer readings from test firings and recommended adjusting chamber spacing to address observed erosion at intersect points. No new firing authorizations accompanied these sheets. Field reports from German artillery units during this period remained primarily concerned with conventional artillery and anti-tank operations. When the staged charge long-range system was mentioned, it appeared in the context of material disposition or equipment transfer instructions. Several unit diaries recorded orders to move oversized components away from threatened depots, with route descriptions and rail scheduling notes. In the margins of some diaries, officers noted that transport could not be completed due to destroyed track sections, and listed the remaining items left in place under guard. Allied intelligence staffs continued to compile summaries of long-range fire incidents affecting London and surrounding areas. These summaries drew on civil defense records, sound-ranging reports, and technical examinations of craters and fragments. The incident logs listed date, time, location, and the sequence of warning indicators. In multiple entries, wardens and observation posts recorded that the interval between first detectable signs and impact was limited, and that classification of the incoming weapon at the moment of attack was frequently uncertain. The same logs recorded the absence of sustained engine noise and the lack of visible exhaust trails that were commonly associated with rocket attacks, where such cues were available. Technical assessment notes appended to some incident reports described attempts to distinguish artillery-fired projectiles from rocket warheads based on fragment characteristics and crater geometry. Engineers recorded the thickness and curvature of recovered fragments, the presence or absence of propellant residues, and the pattern of secondary fragmentation in nearby structures. Where fragments lacked identifiable rocket construction features, investigators marked the incident as probable shell impact pending further corroboration. These assessments were treated as working classifications for the purpose of reporting and did not include broader conclusions. Air Defense Service instructions issued during this period remained procedural. Bulletins to local controllers emphasized the need to continue reporting flash and sound observations, maintain communications discipline, and conduct immediate post-impact reconnaissance for unexploded ordnance. Guidance sheets for wardens included checklists for crater perimeter control, casualty evacuation routes, and the handling of suspected delayed action fuses. The sheets were formatted as operational directives and did not discuss the weapons beyond observable warning and impact characteristics. Within the Allied Air Forces, target lists included sites associated with large underground structures and suspected long-range weapon installations. Operational planning documents show that such targets were categorized under special weapons facilities, and assigned to heavy bomber formations when weather and operational priorities permitted. After-action reports listed tonnage dropped, bomb types used, and observed results. Where cloud cover prevented direct observation, crews recorded bomb release by instrument. Photo reconnaissance flights attempted to confirm crater patterns and structural disturbance on subsequent days. As Allied ground forces advanced, additional technical material was captured from German offices and research facilities. Cataloging teams compiled index registers that included entries such as pressure chamber diagrams, ignition wiring schematics, and propellant composition sheets. Some documents contained hand-drawn cross-sections of a barrel with multiple side chambers, labeled with dimensions and ignition points. Translators produced literal translations and appended unit conversions. Where terms were ambiguous, translators noted alternate readings without inserting interpretive commentary. Interrogation reports from captured German personnel included references to long-range artillery work. These reports recorded the rank and assignment of the person questioned, the date and location of questioning, and the questions asked. Answers were summarized in a structured format. In some reports, individuals described the principle of staged charges along a barrel and the need for timing. Others described construction work at deep installations and the effects of bombing on tunnels. Interrogators recorded statements as given and marked uncertain points where the subject indicated lack of direct knowledge. In April 1945, communications from remaining German ordnance elements increasingly concerned file destruction and evacuation under standing orders for classified material. Document destruction certificates were prepared in some offices, listing file series numbers and the method used, typically burning or shredding where equipment existed. Where burning was performed, staff recorded the time, location, and witnesses. Other offices recorded that evacuation was attempted but incomplete, noting the quantity of material left behind due to lack of transport. Depots holding artillery research equipment issued reports concerning fuel shortages and the inability to maintain temperature-controlled storage. In those reports, officers noted the risk of propellant degradation due to moisture and temperature fluctuations. The language remained confined to storage requirements and inspection findings. In some cases, officers requested permission to destroy sensitive propellant stocks rather than abandon them. Where such destruction occurred, logs recorded the method, including controlled burning or dispersal followed by ignition in remote areas. Railway administration documents from April show increased disruption across central Germany. Waybills for oversized loads were frequently marked cancelled. Where staged charge gun components were listed, the cargo descriptions were generic, identifying steel tube sections, machined rings, or instrument crates, consistent with standard concealment practices. Escort requirements were still listed, but annotations noted that escorts could not be assigned due to personnel shortages. Allied technical intelligence units attached to advancing formations received orders to secure research sites and prevent the removal or destruction of equipment. Site entry reports show that teams arrived at workshops, laboratories, and storage buildings, posted guards, and conducted rapid inventories. Items associated with experimental artillery were photographed in situ before removal. Teams tagged crates and cabinets with evidence seals and recorded serial numbers. Where booby traps were suspected, engineers were called before further handling. In some cases, Allied teams found partial assemblies and test fixtures consistent with stage charge experimentation. These included cutaway sections showing chamber junctions, pressure test vessels, and ignition timing panels. Technical notes written at the time list observed dimensions, wiring layouts, and the presence of calibration markings on gauges. The notes did not attempt to complete missing information beyond what could be directly observed and measured on site. Reports from this stage frequently reference the difficulty of reconstructing full configurations due to missing parts and incomplete documentation. In the same reports, officers listed the materials obtained, the number of crates shipped, and the destinations of shipments. Crates were routed to intelligence centers for detailed examination, and shipping manifests recorded weight, handling instructions, and security classification. Escort details were recorded in movement orders where available. In the United Kingdom, civil defense records through April continued to log impacts and alerts. The records included entries for disrupted water mains, power outages, and transportation interruptions following impacts. Repair crews filed work tickets listing the location of damage, the materials used, and time to restore service. These tickets were filed alongside casualty and shelter occupancy records. In several localities, wardens noted recurring public movement towards shelters at the sound of alerts, followed by rapid deployment of rescue teams after impacts. The sequence of warning and impact remained a recurring procedural concern. Acoustic detection logs recorded the timing of detected sounds and compared them with reported impact times. Where the interval was short, controllers recorded that warning messages could not reach all districts before impact. These entries were recorded as operational facts and used to adjust internal reporting priorities, such as emphasizing immediate post-impact response over attempted weapon identification in the first minutes. Allied analysts receiving these civil defense records compiled summaries to be used for operational briefings. The summaries listed times and locations and included notes on the presence or absence of pre-impact cues. Where classification was uncertain, analysts marked it as such. The language remained within the scope of reporting and did not extend beyond recorded observations and procedural concerns. By late April 1945, additional information about the Mimoyecques installation and related artillery concepts was consolidated within Allied technical intelligence channels. Interim reports were drafted for distribution to relevant commands. These reports included schematic reproductions based on captured drawings, photographs of construction remains, and translated excerpts of German work orders and technical descriptions. The reports described the stage charge principle and noted the intended long-range use of fixed barrels oriented across the channel. They also listed observed bomb damage and the resulting inoperability of key parts of the installation at the time of inspection. As German administrative structures continued to fragment, local commanders issued ad hoc orders regarding the guarding or abandonment of facilities. In some cases, guard logs from storage sites show that sentries were posted until the final days before evacuation, recording shift changes and noting the absence of relief units when scheduled. These logs often end abruptly, with no final entry. Where guards remained until capture, Allied capture reports list the number of personnel present, weapons surrendered, and the condition of the facility. In May 1945, Allied forces entering remaining industrial regions continued to secure documentation and equipment. Technical intelligence teams expanded searches to include private industrial archives where contracts and correspondence had been stored. Company records included purchase orders for high-grade steel, machining specifications, and correspondence about delivery delays due to bombing. Where the records referenced stage charge artillery, the correspondence tended to focus on manufacturing problems, tolerance control, heat treatment schedules, and inspection rejections. Engineers' notes attached to some files listed proposed remedies, including changes in machining sequence and revised acceptance criteria for certain non-critical surfaces. On the operational side in the United Kingdom, municipal services maintained their reporting routines, listing daily repair and casualty figures as required by civil administration. The entries remained formatted for immediate use: what was damaged, what was repaired, which streets were closed, which utilities were restored. When the weapon type was referenced, it was done in the context of the current alert category used by controllers, which was based on available indicators at the moment. Allied technical reports drafted during May incorporated increasing quantities of captured material. These reports described the long-range gun concept as an artillery system employing staged propellant ignition along a fixed barrel and noted that its operation produced fewer external launch indicators than rocket systems, as derived from recorded observations and the absence of certain rocket-associated debris in relevant incidents. The reports were written in measured language, using conditional terms where evidence was incomplete. They included appendices listing document references and photographs. Throughout this period, the documentary record remained centered on procedures, surveying and securing sites, translating and indexing documents, measuring and photographing material evidence, maintaining civil defense and municipal operations, and accounting for stored munitions and components. Entries were dated and attributed to offices and units. The language remained technical, operational, and constrained to what was recorded and handled at the time. From May 1945 onward, the handling of material connected with the staged charge long-range gun proceeded under standing Allied technical intelligence procedures used for captured weapons and industrial records. Field teams operating under established technical intelligence mandates continued to visit sites identified by prior reconnaissance, signals intercept references, and entries found in captured German correspondence. The team's first actions at each location were recorded in entry logs: posting guards, checking for mines and demolition charges, photographing the site as found, and collecting documents from offices, lockers, and filing cabinets before wider movement disturbed the contents. In facilities where personnel were still present, capture reports recorded names, ranks or job titles, and the number of individuals. Where civilian engineers or foremen remained, they were listed as civilian employees or technical staff, with notes on whether they were retained temporarily to identify equipment and records. Transport and shipping documentation generated in this phase took the form of crate manifests and movement orders. Each crate was assigned a number, each number was linked to a short description of contents and the location and date of packing. Handling instructions were written in standard terms: fragile instruments, explosive components, keep dry, do not drop. Where propellant or explosive-filled items were included, additional annotations recorded that the contents required separate storage and examination by explosive ordnance specialists. Escorts were assigned where available. When escort personnel were insufficient or routes were disrupted, movement orders were amended in ink with alternative routing through functioning rail heads or road convoys. Technical intelligence staff created initial equipment lists based on visible items and serial markings. In workshops that had been used for experimental artillery work, lists included pressure gauges, transducer housings, wiring panels, timing relays, and test fixtures designed to hold short barrel sections. Reports recorded the observed presence of calibration markings, scale ranges, and manufacturer plates. Where instruments were not intact, fragments were collected and labeled. In cases where the associated documentation was found in the same room, intelligence officers placed both instrument and relevant papers into the same crate series, noting the relationship in the manifest. In buildings associated with ordnance administration, teams collected filing series organized by reference codes. The staged charge long-range gun project appeared in some of these series among broader artillery development files. Captured binders contained typed memoranda, inspection reports, and ballistic worksheets. Paper clips, rubber bands, and string ties were left in place to preserve document order. Document teams recorded the physical condition of the files, including whether they had been exposed to water or fire. Where partial burning had occurred, officers collected charred pages and placed them into envelopes with notes stating that the text was incomplete. Translation and indexing centers received shipments from the field. Administrative logs at these centers recorded arrivals by date and convoy number, then assigned crates to translators and technical officers. Translators produced literal translations of headings, captions, and key procedural paragraphs. Where documents contained extensive technical tables, translators either provided column headings and explanatory notes or prepared partial translations focusing on data necessary for immediate identification. Index cards were created for each document, listing originating office, date, subject line where present, and a brief content description. Cross-references were written to link related documents by project code, author name, or location. Technical officers working alongside translators prepared short identification notes intended for distribution to commands responsible for air defense, civil defense liaison, and weapons assessment. These notes were confined to describing the existence of a staged charge gun concept, the method of timed ignition along side chambers, and the fixed installation form involving deep inclined shafts aimed toward a distant target. Where documentation did not allow a statement to be made with certainty, the notes used conditional phrasing and referenced the specific document number. Attachments included copied diagrams and photographs, labeled with date and capture location. In the Pas-de-Calais, engineering detachments continued to treat the Mimoyecques underground installation as a safety and demolition problem. The site was logged as hazardous due to unstable chalk and prior deep penetration bomb damage. Entry permissions were controlled by local commanders. Inspection reports from May and June recorded that many galleries remained inaccessible. Survey teams used probing rods and measured air flow at blocked passages to assess whether large voids remained behind collapses. Where voids were suspected, teams marked the areas on sketch plans and recommended further sealing. In sections where access was possible, teams recorded the presence of rails, concrete lining, and mounting structures. Any remaining metal segments embedded in concrete were noted by approximate size and location rather than removed, unless removal could be performed without additional collapse risk. Explosive ordnance personnel inspected the surrounding ground for unexploded bombs and demolition charges. Their reports listed the number of items found, the fuse types were identifiable, and the method used to render them safe. For items too dangerous to move, controlled detonations were carried out. The results were described in terms of crater formation and the effect on nearby structures. When controlled detonations affected parts of the underground complex, officers recorded that further entry should be postponed until stability could be re-evaluated. Civil administration in the United Kingdom continued to maintain routine reporting systems through May 1945, including records of repairs and casualty assistance tied to earlier long-range attack incidents. Local authorities processed outstanding claims for property damage and maintained registers of temporary housing allocations. Repair crews filed completion notices for work on gas lines, water mains, and electrical cabling damaged by impacts, listing the materials used and the number of labor hours. Transport authorities logged track and road repairs. In districts where earlier alert systems had required rapid sheltering, wardens and civil defense staff filed final monthly summaries of shelter occupancy and equipment condition. These summaries were written in a standard administrative tone and included counts of helmets, stretchers, first aid supplies, and communication sets returned to stores. Air defense and warning networks maintained records of equipment status and communications reliability as part of routine readiness and later stand-down procedures. Logbooks recorded maintenance actions on microphones, plotting boards, telephone circuits, and generator sets. Where items were decommissioned, entries recorded the date and the destination of equipment, often municipal storage depots. Technical staff filed certificates for the return of borrowed equipment to national stores. In places where warning procedures had been adjusted because of short warning intervals, staff preserved the procedural instructions in station files, with annotations noting the date ranges during which those procedures had been active. In Allied headquarters and technical intelligence centers, the consolidation of captured material continued. Officers prepared interim summaries for limited circulation, listing what had been captured and what remained unknown. These summaries included enumerations of documents by date range, lists of equipment recovered, and a description of the condition of the principal installation site. Where ballistic tables were found, officers noted the ranges and projectile weights shown in those tables, without supplementing beyond what the documents recorded. Where pressure charts were included, officers reproduced the chart axes and labels and noted whether the chart was complete or partial. Captive personnel interviews continued in parallel. Interrogation teams followed established protocols, recording the subject's identity, unit or employment, and the dates of their association with particular facilities. Questions were asked about assigned tasks, chain of command, and procedures used in workshops and depots. Answers were written in the interrogator's summary style, with direct quotations used sparingly. Where a subject described the stage charge method, interrogators noted whether the subject claimed direct participation or only second-hand knowledge. Where subjects described the underground installation, interrogators compared the statements with survey findings and marked points of agreement or uncertainty. These interrogation reports were filed with the captured document indexes for cross-reference. Industrial records from German firms were collected and examined under the same procedures used for other weapons projects. Purchase orders and invoices showed steel grades, machining services, and inspection fees. Quality control records contained rejection tallies and notes on surface defects, dimensional deviations, and heat treatment inconsistencies. Some records included meeting minutes between firm engineers and military inspectors, listing agenda items such as barrel segment tolerances, side chamber drilling alignment, and the handling of cracked test pieces. In these minutes, actions were recorded as assignments: to repeat a heat treatment cycle, to adjust a drilling jig, to resubmit a sample for proof testing. Where dates were present, they were preserved in the index so that sequences could be reconstructed by the intelligence staff without adding narrative beyond what the records contained. Proving ground files captured from ordnance sites included firing logs and range safety reports. Where stage charge trials were recorded, the firing logs listed test numbers, charge configurations, and measured pressures. Some entries included notes of misfire events and the subsequent actions taken: clearing procedures, disassembly of ignition leads, and replacement of connectors. Range safety reports listed the placement of observers and the boundaries used for exclusion zones. Meteorological sheets attached to firing logs recorded wind speed and direction, temperature, and barometric pressure. Technical officers examining these files photographed key pages and prepared literal extracts for the internal record, focusing on data points that aligned with known stage charge procedures. In several cases, Allied teams recovered partial barrel sections or cutaway models intended for instructional or test use. Handling reports described the weight, the bore diameter, and the presence of side ports consistent with auxiliary chamber connections. Where measurement was possible, teams recorded the spacing between ports and the angle of intersection. If markings indicated the intended orientation, these were noted. Engineers then recommended whether the piece should be shipped intact, cut for easier transport, or examined on site. The chosen course was recorded in the movement order, and the reason was stated in practical terms such as bridge weight limits or lack of lifting equipment. The movement of captured explosive material required separate procedures. Explosive ordnance officers inspected projectile bodies and charges before allowing shipment. Reports recorded whether explosive fillings were present, whether fuses were installed, and whether the items had been stored under appropriate conditions. Where items were considered unsafe to transport, officers ordered on-site destruction. Destruction logs recorded the method, the location, the personnel present, and the time. Where transport was permitted, crates were labeled with hazard warnings, and the receiving site was required to confirm receipt and storage conditions. As the summer approached, the administrative process of closing or repurposing captured sites continued. Local commanders issued orders for fencing, posting warning signs, and restricting access to unstable underground structures. In the Pas-de-Calais, the main concern remained the integrity of collapsed galleries and the possibility of unexploded ordnance. In industrial regions in Germany, the main concerns were the safe handling of chemical stores, the clearing of damaged buildings, and the prevention of unauthorized removal of equipment and records. These concerns were reflected in daily guard logs and engineering notes, which recorded patrol routes, discovered damage, and changes in access control. At intelligence centers, compilation work produced a set of consolidated reference files. These files typically included a translated description of the stage charge principle, copies of key diagrams, selected ballistic and pressure tables, and photographs from surveys and recovered equipment. The files were distributed under controlled lists, with recipients signing for receipt. Filing clerks recorded any subsequent relending of the files to other branches. Where additional captured material arrived that appeared relevant, clerks updated the cross-index and inserted new pages into binders using standardized insertion slips stating date and source. In the same period, air defense reporting channels in the United Kingdom and on the continent continued to exchange information regarding projectile impacts attributed to long-range fire, where such incidents had occurred previously. With the change in operational conditions, the practical use of these channels shifted toward record completion and the archiving of logbooks. Officers responsible for these archives recorded the disposition of station logs and the storage location of paper files. Items deemed unnecessary for retention were listed for disposal under routine administrative procedures, with disposal certificates when required. Municipal and civil defense services, where they had been expanded for wartime conditions, proceeded with the return of equipment and the release of personnel. Service rosters recorded end-of-duty dates. Equipment inventories recorded the return of radios, field telephones, and protective gear. Buildings used as control rooms and shelters were inspected for structural condition and sanitation requirements before being handed back to civilian authorities. These inspections generated checklists and completion forms. The forms listed broken fixtures, required cleaning, and repairs completed, without narrative beyond the items on the list. On the technical side, Allied officers examining the long-range gun material continued to note the operational indicators that distinguished artillery-fired projectiles from rocket attacks in immediate observation records, without extending the notes beyond their reporting purpose. Where impact reports contained no engine noise reports, no visible exhaust trail, and fragment characteristics inconsistent with rocket structures, analysts kept those entries in the category used for probable artillery. Where evidence was inconclusive, entries were left as unclassified or unknown, consistent with reporting practice. Analysts used these categories to organize files rather than to form broader statements. In the weeks following the consolidation of captured German documents, Allied technical officers drafted formal memoranda for internal distribution describing the staged charge gun as documented in captured records. These memoranda were written in the style of technical notices, stating that documents indicated a long fixed installation, describing the method of auxiliary charge ignition along a barrel, listing known sites and the status of those sites at the time of inspection, and attaching copies of diagrams and translated extracts. Where the memoranda referred to intended ranges, they cited the captured ballistic tables and noted the assumptions stated in those tables where present. Where the documents referenced specific projectiles and propellant arrangements, the memoranda listed those configurations as recorded. All documentation produced in this phase remained tied to procedures and recorded observations. The sequence of actions was logged as a sequence of tasks: securing sites, assessing hazards, collecting records, indexing and translating, shipping equipment, and updating internal reference files. Reports identified who performed each task, what was found, and where it was sent. Where uncertainty existed, it was recorded as such. Where information was missing due to destroyed records or inaccessible structures, reports noted the limitation in plain terms such as documents not recovered or area inaccessible due to collapse. By the end of this phase, administrative and technical records related to the staged charge long-range gun were organized into controlled archives and technical intelligence collections. The records preserved the original wartime forms, memoranda, firing logs, engineering plans, work orders, depot inventories, and survey notes. The handling of these records, as documented at the time, followed established practices for the management of captured material and intelligence material, cataloging, translation, controlled distribution, and secure storage.